So in this video, I'm going through semester 1 and short test 1, the practice paper. And these are the topic that will be in the short test. So the first question is a multiple choice question, and it really is about adding logs. ln and logs work in exactly the same way. So when we add, we multiply that part. So this is ln 4x times 5x, which is 20x squared, and it equals 8. To solve any equation with ln, I am going to take e to both sides. So ln and e cancel to give us 20x squared, and this is now e to the power of 8. So first thing I do is I divide by 20, so e to the power of 8 is 20, and therefore x is the square root of e to the power of 8 over 20. And the question says solve the equation for the positive solution, so it's not a plus minus, it's simply the positive solution. And I put that into my calculator, square root, fraction, shift, ln, and 8, so e to the power of 8, and then divided by 20. And that gives me 12.21 to 2 decimal places, which is this one, 2 decimal places. Question 2 says, if cos x equals negative 3 over 5, what is the value of cos 2x? So you would look at your formula sheet and you might notice that cos 2x is the same as 2 cos squared x minus 1, which means that all I need to do is to substitute. I know the value of cos x, so 2 times negative 3/5 squared minus 1. And again, you simply put that into your calculator, 2 brackets, negative 3/5, close brackets, squared minus 1. And that is negative 7 over 25. Question 3, 25 log r5 equals log 5r. You might notice that I have a base of r and a base of 5, 2 different bases, so I can use the change of base formula. So this is log ab, log to base ab, is the same as log cb divided by log ca. So the base is at the denominator, and I choose a different base, a base that I want. Well, I want the base to be 5, because that's the number. I don't want it to be algebraic. So this is what I will do. 25 times, that has to be on top, and I'm going to choose base 5. So log base 5, 5, divided by log base 5 r equals log 5r. Well, log 5 is 1. What power of 5 gives me 5? That is 1. So now I have an equation that looks like this. 25 over log 5r equals log to base 5r. What I can do is I multiply this up. So basically I multiply something by itself. Let me go here. So this is going to be 25 equals log to base 5r all squared, because I multiplied it by itself. I want to find log to the base 5r, so I have to square root. When I square root, I always get 2 answers. Therefore, I have shown that log 5r equals plus or minus 5. This question says the function g of x is defined as g of x is 2 ln x plus 5 divided by ln x minus 3. X is bigger than 0, and you are told that x cannot equal k, and k is a number, it's a constant. And the question is deduce, find the value of k. Now, this is a question about functions and about restricting the domain. And we know that when you have a division, a fraction, the denominator cannot equal to 0. So how are we going to know what is restricted? We need to only focus on the denominator. ln x minus 3 cannot equal to 0. So ln x cannot equal to 3. And how do I solve this? I take e to both sides. So x cannot equal to e to the power of 3, which is this one. And then the final question, which is the one with the most marks, 4 marks. Show that 3 tan x minus cot x equals 4 cosec x may be written in the form 4 cos squared x plus a cos x plus b equals 0, stating the values of the constants a and b. Well, I need to change all of these things, and I'm going to change 3 tan x to 3 sine x over cos x. And then cot is 1 over tan, which is 1 over sine x over cos x. So it is cos x over sine x. And that equals 4 times 1 over sine x, which is 4 over sine x. So 4 over sine x. Because the left-hand side is a subtraction, I cannot subtract unless I have common denominators. So I'm going to multiply this by sine x, and the top by sine x as well. And I'm going to multiply this by cos x, and the top by cos x as well. So at the top here, all of this is a multiplication because this is 3 over 1. So I have 3 sine squared x, and then I'm multiplying these two minus cos squared x all over sine x cos x, or cos x sine x, equals 4 over sine x. So I don't really want this as a fraction, so I'm going to multiply, okay, so times sine x cos x over 1. And this I can turn into a cos squared x because I can see that all of this is in terms of cos. So cos is what I'm aiming for. So 1 minus cos squared x, that's one of the oldest identities that we know, minus cos squared x equals, and I hope you can see that this sine x cancels with this sine x when we multiply. So over here I have 4 cos x. That's a 1, that's a 1. I then multiply out the bracket. So 3 minus 3 cos squared x minus cos squared x. I'm going to move this to this side, minus 4 cos x equals 0. These are my like terms. So minus 3 cos squared x minus 1 cos squared x is minus 4 cos squared x. So 3 minus 4 cos squared x minus 4 cos x, and it's starting to look like what I want, but I want the cos squared to be positive, so I'm actually going to move everything to the other side. So 4 cos squared x plus 4 cos x minus 3. So it looks like what I want it to look like. A is 4, B is negative 3. A is 4, B is negative 3. And that is the end of the test.